But suddenly, the universe started breaking its own rules. Galaxies appeared too early. Space began expanding at two different speeds, and enormous structures showed up where none should exist. This might be the most exciting time in modern astronomy. For decades, scientists believed they had a solid understanding of how the universe works, how it began, what it's made of, and how it evolves. The model was elegant, powerful, and surprisingly accurate. It explained almost everything we observed. Almost. Because recently, something strange has been happening. Thanks to powerful new telescopes and sharper data, the universe has started behaving in ways we didn't expect. And instead of fixing the gaps, new observations are making them bigger. What once looked like tiny errors now feel like warning signs that something fundamental might be missing. And that's not bad news. That's how scientific revolutions begin. History shows us this pattern. When astronomers noticed Uranus drifting from its predicted path, they didn't panic. They discovered Neptune. But when Mercury refused to obey gravity, the solution wasn't another planet. It was a completely new idea, Einstein's theory of relativity. So today, we face a similar question. Are we about to discover a missing piece or rewrite the rules entirely? Across the cosmos, astronomers are finding enormous structures that shouldn't exist according to our current models. Galaxy walls and rings stretching billions of light years across, and massive empty voids where almost nothing exists. Our best theories say the universe should look smooth and uniform on very large scales. But these discoveries challenge that idea. If the universe isn't uniform, then our view of it might be deeply biased, like judging an entire cake by tasting only the cherry. We know the universe is expanding. The problem is that different methods give different expansion rates, and the disagreement keeps getting worse. It's as if two perfect instruments are both correct, yet disagree completely. The odds of this being a coincidence are now extremely small. Something is wrong, either with our measurements or with our understanding of space itself. Then came the James Webb Space Telescope. Almost immediately, it spotted massive, bright galaxies from a time when the universe was still a baby, far earlier than our models allow. Even more surprising, these galaxies appear mature, containing heavy elements that should take generations of stars to form. It's like finding adults in a nursery. Either galaxies formed much faster than we thought, or we're missing a huge chapter in cosmic history. These aren't isolated problems. Lithium doesn't match predictions. Dark matter behaves strangely. Dark energy may be changing over time. Even the cosmic microwave background, once considered untouchable, is being re-examined. Scientists are divided. Some believe these issues will fade with better data. Others think a major overhaul is coming. And for the first time in decades, no one knows what cosmology will look like next. In science, a crisis doesn't mean failure. It means progress. Every major leap in understanding begins with confusion, when reality refuses to fit our stories. Eventually, a deeper truth emerges. Whether we're about to discover a cosmic Neptune or face a cosmic Mercury moment, one thing is certain. The universe is telling us our story isn't finished yet. And that makes this one of the most exciting moments in human curiosity.